Hello, welcome to my channel. My name is Prasad. In this video, I'm going to talk about data integration. I'm going to explain the concepts in a very practical and project implementation standpoint. So without further delays, let's get started. So as we all know, in a typical enterprise, so data flows from multiple sources, be it POS, OLTP, or any legacy systems, or it could be even a simple flat file or even a CSV file, which is being generated by an operator. So an enterprise, literally, I would say the enterprise gets data in every format. And uh, so how all these data is getting integrated and let's say if the company's uh, top executives, if they wanted to see a consolidated report, a financial report or a forecast report or any kind of trend analysis. So how do we consolidate the data coming from these systems and how the relationships are built and how the data is persisted in a central repository? So this is where the concept of ETL comes into picture. ETL stands for extract, transform, and load. And actually, there is a parallel approach to this process. It's called as a ELT, which stands for extract, load, and transform. I'll touch base about ELT towards end of this presentation. But now let's talk about ETL in general. So as I said, the data comes from a wide variety of sources, right? So uh, in order to so the first step of ETL is to extract the data. So when we talk about extraction, it could be an incremental extract or a full refresh. So let's say if you're doing a migration for the first time, let's say uh, if you're migrating data from uh, Oracle to a data warehouse database like Teradata or or any modern data warehouses like cloud data warehouses like Snowflake. So initially we do a full extract and with history data and data will be dumped into the target. So upon subsequent loads, the data, we don't need to get the full records, right? So that's when we do, I mean, there is a concept called as incremental extract. So the data will be extracted incrementally and it will be loaded. So this is a concept about extraction. So as I said, we have two types of extract. One is the incremental, and let's say if the data is all about if it is about some reference data or some dimensions, so which needs a full refresh. So the full dump of records will be extracted from the source and it will be loaded into target. And likewise, when we talk about the various use cases, we have basically, I would say at a very high level, there are two kinds of loads. One is a batch load, and the next one is a streaming or a real-time load. Even within batch load, we have several types of batches like mini batch, micro batch, kind of it. So broadly speaking, these are the two varieties of loads. One is a batch load and a stream. Batch, as the name suggests, the data will be batched on a regular interval and it will be cascaded further. So this is a typical scenario for loading a data into a warehouse. So I would say majority of the data migration uh, which deals loading data into a OLAP system will comprise of the batch loading. Okay, so what about streaming? So let's say if you wanted to load some streaming data, let's say it could be a data coming from IoT sensors or anything, so GPS trackers. So those kind of those kind of loads are called as the streaming loads, streaming or near real time data loads. So once the data is extracted, so here comes the ETL tool. So we have several market leading ETL tools like Informatica, Data Stage, SSIS, and some of the modern compute engine tools like uh, Hadoop, Databricks, and Spark. So basically, they act as an interface connecting to the source system, and these tools support various connectors, each catering to different source systems. So basically, they connect to these source systems extract the data, and it processes the data. So when we say data processing, it could be anything like data aggregation and doing lookup, joins, filtering, merging, removing duplicates. I mean, converting data from one form to another. It can be anything. So the list is endless. So how the layering would happen is the data will first be extracted from the source system and it will be loaded into a staging layer. So the staging layer will be like an exact replica of the source systems. So as such, the staging layer will not involve any kind of transformations or nothing. It will be like a direct map from the source, and the data will be just dumped into the staging. And once we have the data in the staging, so while loading the data from staging to target, that's when the transformations will be applied. So it transformations and business logics will be applied, and eventually the data will be loaded into the data warehouse. And if you want to say about the enterprise data warehouse in a very simple term, it's called as a centralized repository to store the enterprise wide data. So mostly it will be a normalized data, and even within data warehouse to cater to any specific reporting needs, the data will be denormalized, and we can have a customized dimensional modeling to align with the reporting requirements. So when we talk about the enterprise data warehouse, so we have several market leading databases like Teradata, uh, SQL DB, which is part of Azure's data warehouse product. And likewise, we have cloud products like other cloud products like Snowflake, BigQuery, and Redshift. So again, the list, whatever I have provided here is not an exhaustive list. So it is just an illustrative list for you to get the gist of the products. And so this is a very high level uh, picture of data migration from source to target. So once the data is loaded into EDW, so this will the data needs to be visualized, right? So that's the whole idea about having data. We need data to be visualized in a very meaningful form for the top management uh, uh, to use it. So here comes so basically this is the layer where we employ the reporting tools. So in general, this is called as the presentation layer. So wherein we employ several ETL tools to cater to our reporting requirements. So again, I have listed few of the reporting tools here, that is Click and Power BI. Again, this is just an illustration. So depending upon the use case and depending upon the volume of data and other requirement, the choice of the reporting tool would vary. And also, let's say if your project already has Azure Stack for data engineering activities, so Power BI will be a very natural choice. However, some projects it will also employ tools like Click, ClickSense, Click, etc. So it depends upon the, as I said, it all depends upon the project requirements. So this explains the ETL landscape. And as I mentioned at the beginning of the video, so we have a parallel approach called as a ELT. So basically ELT stands for extract, load, and transform. So in principle, the main difference between ETL and ELT is, as far as ETL is concerned, the transformation will be done on the fly, which means, let's say, if I'm extracting data from Oracle and loading it into Teradata, so all the intermediate transformations and other conversions can be handled directly by the ETL tool. So in short to say, the computation power will be handled by the computation engine will be handled by the ETL tool. Let's say if let's take an example. If we are using Informatica, means Informatica does all the conversions on the fly, and eventually it loads the data into the target. On the contrary, if you are employing ELT approach, right? So we don't employ the compute engine of the ETL tool. Rather, so ETL will act as only as an interface. So it will just extract the data. We'll first extract the data and dump it into a persistent layer. It could be a table or a flat file. So let's say if the data is coming from multiple sources, right? So we don't need to do anything on the fly. Rather, we extract the data and dump it into a table or a file, and we employ either the database engine or any other third-party compute tools like Spark or Databricks to do the computations. So let's say if I have all the data in the staging, let's say if my target is in Teradata, so or SQL Server. So what I will do is I will just store the data in a staging layer, and by making use of stored procedures, I will make all the transformations and apply the business logic inside the stored procedure, and with and load the data and cascade the data further into the target layer. So the main advantage with this ELT approach is we don't need to be completely reliant on the hardware and other infrastructures of supplied by the ETL tool. Rather, we just need ETL tool to make the interface. We just need the ETL tool to act as an interface. And all the compute workload will be handled by the database engine, or if we have a Spark cluster, then we can make use of Spark cluster to the computing capabilities. So this is a very fundamental difference between ETL and ELT. And to add on, ETL is a very contemporary approach. So if you're dealing with any kind of modern data warehouse architecture, we will only make use of ELT approach. So with this, I come to end of my presentation. I hope you would have enjoyed this video. So please do comment, and yeah, thanks for your time. Bye.